a chance to talk to you guys about decentralized science, or DeSci, and how it may actually help us to improve science and to make it more replicable. And so I'm going to structure my talk into four broad categories. So I'm going to start out with a little bit of a rant. So I'm going to talk about what motivated us to start the DeSci Foundation and DeSci Labs. So both of them actually got started last summer, so it's only a year old. And then I will say a couple of words about how I would describe the overarching vision of the DeSci movement. So the DeSci movement is much, much broader than what we're doing at DeSci Labs and the DeSci Foundation. There's really, in the last couple of months, there's a lot of amazing grassroots initiatives that have started to take shape, where a lot of people like technology pioneers and scientists are coming together and thinking about new ways how we can use Web3 technologies to improve science in one way or another. And this is really, it's a really nascent movement that started to gain traction, I would say, probably around October last year, when there was the first DeSci meeting at ETH Denver. And then it started to gain an enormous amount of momentum in the last couple of months. So it's a really, really exciting environment to see grow. So the third thing I'm going to talk about is then what we're actually building at DeSci Labs. And then I will wrap it up by giving you a demo of our first product, which are the DeSci nodes, which is basically the infrastructure that we're creating for scientists to store and to share their research as interactive and integrated research objects. So it's a one-stop solution where you can store your manuscript, your data, your code, but also videos and annotations and peer review, all in an openly accessible research object that is indexed on chain and that is immutably stored on a decentralized network. And that's the infrastructure on which we will build. Okay, so let's see if I can actually advance my slides here. Yes. Okay, so let's start with the rant. So the major reason why my co-founder Chris and I originally started to think about how we can use Web3 technologies to improve science is that we were both incredibly frustrated with the replication crisis that we have in science. And this is, of course, you guys know all about this. You have this amazing grassroots movement. And yeah, just as a reminder, I mean, the replication rates that we're seeing in the social sciences from recent large-scale studies, they suggest that we can only replicate about 50% of the published research. So you basically, when you read a paper in a top psychology or top economics paper, what that means is that you basically have the chance of a coin flip that the result that you're reading is actually true or not, right? And that's completely unacceptable. And it gets even worse in other fields. So, for example, there was this study that was published by people from the biotech giant Amgen, that was published in Nature in 2012, where they basically reported their replication results in their own laboratory, where they tried to replicate over 50 landmark cancer studies, so preclinical cancer studies. And they only managed to replicate about 10% of those published results in their own lab. And that's, of course, it's a total catastrophe, not only for the company that has wasted a lot of money for it, but also for society at large and for patients. There's also this problem that non-replicable publications are apparently cited more than replicable ones. And even having negative replication results barely changes the citation frequency of the original results. And only 12% of post-replication citations acknowledge the replication failure. So there's also something wrong with how we as scientists actually approach and think about and talk about the replicability of work. And a part of it is also that the journals clearly do not like replication studies as much as they like novel and attention-grabbing results, right? So if you look at psychology journals, only 3% of them actually explicitly encourage replication studies at all. And in many, they explicitly say that they do not publish replications, right? And that actually hints at much deeper institutional problems that we have in science. So I would argue that probably the biggest problem that we have is really this publish or perish, or even impact or perish culture, where publications and citations are the #1 currency for scientists, and as a result, high impact journals have become these powerful gatekeepers for the personal success of people in academia. So both in terms of like getting jobs and getting promoted and getting grant money. And now actually just having high standards for academic publications is obviously a good thing, but the current business model of publishers has decoupled impact and replicability. And that contributes, in my opinion, to the current replication crisis, right? So essentially what the journals are doing is that they operate in an attention economy, and they try to maximize views and citations to sell their products. And that means that novel, surprising, and provocative results are more likely to be sought after by editors and journals. Even though, by definition, if a result is both novel and surprising, it's also less likely to be true. And that results in a situation where a lot of the high-impact science is unfortunately little more than clickbait that leads to more confusion and false information than to actual scientific progress. And if you look at the potential solutions of this problem, such as having open data and open code, or pre-registered analysis plans, or actual replication studies, those are rarely incentivized by journals or by universities or by funding agencies, and they are hardly ever strictly enforced, right? And in order to change that, we actually need to change the incentives for scientists directly. And this is actually one of the things where I think DeSci can really play a big role. The second part here is, of course, the business model of the publishers themselves. So at the moment, what we have is basically only two business models for science publishing. One is pay to read, and the other one is pay to write. And both of them are problematic for their own reasons. So pay to read is problematic because it basically locks up more than 80% of the world's scholarly output behind paywalls that are not accessible to the vast majority of humans on the planet, including the taxpayers that have actually financed a lot of the work that has then disappeared behind the paywalls. And the pay-to-write publishing model is also problematic because, well, first of all, it's really expensive. So even if you go like to a low-cost, open access journal such as PLOS ONE, you're still paying typically north of €1,000 per publication. And then journals like Nature Communication or Nature Neuroscience, they now charge you €9,500 for an open access publication, right? So, and that's I would argue that this borders at extortion, right? So these are just incredibly high prices. But that's not the main problem, it is a problem, but I think there is an even deeper problem that is underlying this business model, which is basically, if that's your way as a publisher, how you're making money, then you basically have an incentive not to reject people, because every time you reject a paper, it means that you're losing revenue. And as a result of the rise of this, pay-to-write business model, we now have this inflation of, all these predatory journals that ultimately are no quality filter whatsoever, but that are primarily just out there to get money from scientists to put up whatever bullshit they want, right? And that again is an actual threat to the integrity of the scientific record. I actually understand why publishers like these business models so much. I mean, they're highly profitable, right? So the entire publishing industry is like making $19 billion revenue annually, and the publishers, the big five, they have profit margins around 40%. So some of the highest profit margins you will find in any industry. And a part of it is that they can rely on unpaid referee work. And it's ultimately us, scientists, who are writing the referee reports for them, that are providing the main service that they're selling, right? So they're basically selling an approval stamp, but the approval comes from us, the scientists, who do that work for them and who are not getting paid. And there was this interesting paper that came out last year, which basically estimated the hours spent by academics in the US and Great Britain and in China that they spend just on peer reviewing for journals, and then try to estimate what the monetary value of that labor is. And it turns out that if you just look at these three countries, that alone is equal to a multi-billion-dollar donation from scientists to the publication industry every single year, right? So, and as a result, you're not surprised that referees are fed up. The number one pain point for editors nowadays is that they have problems finding qualified referees who are willing and able to do referee reports on time, right? And we all know that from our own experiences. So my personal threshold for saying no to a invitation to review a paper has fallen substantially in the last couple of years, and a lot of people, like really respected and influential academics, they're literally and publicly going on strike. They're saying we're not supporting the system anymore, we're not doing peer review anymore, and there is this 450 movement where scientists are arguing that they should get paid $450 for each referee report that they're writing. So whether this is realistic or not, this is debatable, but it just shows that there is something happening that seems to disrupt how the current model is working. Another big problem in science is, of course, the way how we finance research, how we fund it. Probably the most inefficient way of doing that is through competitive research grants. So the funding rates there have actually decreased for most major funding institutions in the last couple of years and decades. So in the US, for example, for the NIH, funding rates have plummeted from what used to be around 40% in the 70s to about 10% now. And that means that an enormous number of researchers every year are wasting time writing proposals that are not getting funded. And there are some estimates that the waste in writing proposals may be comparable to the total scientific value that is being created by these grants. There's also a Matthew effect where people that just got lucky and that were just above the funding cutoff line end up getting much more grant money in the future than those that ended up below the cutoff line at the beginning of their career. We have a situation where, because of the grant funding system, a lot of interdisciplinary, out-of-the-box, innovative ideas are not getting funded because they're not fitting into the more risk-averse preferences of the funding agencies, and they don't neatly fit into categories that referees are comfortable with and that they feel comfortable endorsing. And there's also evidence that just the entire peer review system of grants is highly ineffective, so that the peer review percentile, for example, seems to be an extremely poor predictor of how productive the research ends up being in terms of number of publications and citations. So there's a lot of things that are really going wrong. But maybe the most worrying thing is that if you just take a bird's eye perspective and you just look at this thing from a macro point of view, it seems to be that there is increasing evidence suggesting that the overall returns to investments into science have decreased in the last couple of decades. So I'm showing here just two figures from a paper by Bloom et al. That was published in the American Economic Review last year. And on the left, this is basically a case study that just illustrates this overarching point for cancer research. So you see productivity in cancer research measured in years of life saved per clinical trial or per publication. And you see that the productivity peaked around the late 1980s. And since then, there seems to be a rapid decrease, right? So although all the big innovations that have come through, such as the genomics revolution, the internet, the dramatic improvements in computing power, and many other breakthroughs, they happened way after that, and they should have helped with the productivity of cancer research, but they apparently haven't. And if you look at the right, you see that the problem is not that we're not spending enough on research or that we don't have enough scientists. So at the opposite, it's actually we're spending more on R&D than we ever have in human history, both in absolute and in relative terms in most OECD countries. And in this picture, you see that the effective number of researchers has also increased over time, but research productivity, measured as total factor productivity growth, has been falling. So, and if that trend continues, we literally face a problem as a species, right? So if we're not able to make sufficient scientific progress anymore, that means that we will not be able to solve the coming crisis in the future, and that we will definitely have problems maintaining our level of economic growth and just well-being that we derive ultimately from scientific progress. Okay, so that was the Rant part. Now let's talk about DeSci, right? So there's a lot of different definitions or ways how people talk about the DeSci movement. And as I was preparing for this talk, I was thinking about how would I actually describe this, and I would probably summarize it with 4 main bullet points. So I would say that DeSci is about truly open access, explicit incentives for reproducible research, or more generally about better incentives for scientists. It's also about finding a better peer review system, making improvements with the peer review system, and to find better and more efficient ways of actually financing research. So these, I would say, are the 4 overarching goals of the DeSci movement. And DeSci always implies that that people are thinking about using technologies that are based on Web3 to enable these solutions. So I'll say a couple more words about what I mean with truly open access and explicit incentives for reproducible results on the next few slides. But just a little excursion here. So when I talk about a better peer review system, what I have in mind are, so there's various approaches to do that, but the approach that we're taking at DeSci Labs is we're thinking about a system where we basically have a technology toolkit that allows scientists to come together and to self-organize as scientific societies, and then to offer peer review services to the academic community, and to then reward good referees for the work that they're doing with income streams that primarily come from a new class of digital assets that these scientific societies could use to generate revenue. So what I have in mind there are things like peer review tokens, open science certificates, or also digital art that illustrates outstanding research and that actually has a monetary value in itself. And when it comes to more efficient funding, again, so there's a lot of really cool ideas out there, and probably Web3 is more suitable for really breakthrough improvements in how we finance things in general, but also how we finance research, because it does have this integrated control or possibility to actually control financial value and to enable financial transactions in a very natural and system native way. And most ways how people are thinking about improving funding has an element of crowdfunding baked in. And then there's 2 meta ideas that have gained quite a lot of popularity in the last couple of months. One is impact certificates. So I'm not going to talk here about what they are, but if you're curious about this, we actually have a talk on our DeSci Labs channel on YouTube that talks about impact certificates, what they are and how they can help us to finance research more effectively. And then there's this other really cool idea of IP NFTs, where you basically use Web3 native tools to have crowdfunding campaigns that ultimately allow different people to come together and invest into really early stage projects that can ultimately lead to intellectual property rights or patents, right? So if you're interested in that, I would encourage you to check out what the guys at Molecule and at VitaDAO are doing, who have been pioneering this. Okay, now a couple more words about what I mean with truly open access. So with truly open access, I mean universal accessibility of research, and that implies that we need an infrastructure that actually makes this possible. And I think that Web3 is amazing for that because it allows us to store research on decentralized networks that are not subject to a single point of failure anymore. So we don't have a central entity anymore that if that is corrupted or goes bankrupt, that everything is lost, right? So everything is decentralized and is basically also redundant on various servers that are operated by different entities around the globe. And then the entire record is actually indexed on an immutable blockchain, right? So that means you're actually creating an immutable public record of research. Universal accessibility also means no paywalls, no author publication charges. It means also that we need a technology to actually have truly unique and permanent identifiers for research. And you may think, well, we already have that. The DOIs are supposed to be that, but the DOIs are failing like on a massive scale. So DOIs are neither unique nor permanent. They actually don't satisfy any of the requirements of a good identifier. And again, this is something where Web3 technologies come in and they offer very elegant and convincing solutions. Universal accessibility also means that the work that researchers put up there should generally happen under a Creative Commons license, right? So that means that it's broadly accessible to a lot of people, but it also means that the authors themselves are not restricted from actually still publishing their work with traditional journals where they would have to give up their copyrights. But at least in this open environment, CC0 is the way to go. Truly open access means, in my eyes, also open reproducibility. So ideally, we want to have a system where anybody can come in and they can check out the data and they can check out the code and they can just click on one single button and basically reproduce the main figures and the tables of a research paper, right? And that means that from a technological point of view, we need to move away from the static PDF or just the main manuscript of the paper towards a more holistic way of thinking about research. So we're proposing that we will actually use research objects for that. So research objects that are basically a one-stop solution where you have the data, the code, the manuscript, annotations, videos, all of these things combined in one place with a perfect track record, with version history control, and where everything is integrated front end to back end, where the paper is linked to the code is linked to the data, and you can ideally really just click a button to reproduce the core results. So that's what we mean with open reproducibility. And then finally, a part of open access is also that the way that research is being verified and peer reviewed should be in the open, right? So currently, of course, peer review happens behind closed doors. You hardly ever see what is going on there. You only see the final outcome that something was accepted in a journal. You don't know what the paper trail was leading up to that. And open verifiability would change that and would basically put all of these things in the open and also enable a broader number of experts and people to actually interact with the research object and to comment on it and to leave annotations. Okay, explicit incentives for reproducibility and replicability. So I think that a really cool way of doing that is actually with badges that would be peer reviewed and that would be granted by experts in the field and that would verify different degrees of reproducibility and replicability. So I will show you an example of that a little bit later. And we would also need to have a user-friendly technology that actually enables code dockers to reproduce results. And we may want to have a system where people can literally create financial incentives for researchers to conduct an independent replication study for a result that they're particularly interested in. This is also one of the things that that will be possible in our system. And then finally, so explicit incentives for reproducibility in my mind also include a verified badge for fair data. And fair data basically stands for data that is findable, that is accessible, that is interoperable, and that is reusable. So all of that is super important for reproducibility, and we can actually have badges for that that are actually verified by peer reviewers, and thereby create a distinct marker for research that actually does have fair data and gives authors an incentive to actually invest into going beyond the call of duty and actually making sure that their data is fair. Okay, so now a couple of words about what we're building at DeSci Labs. So we're really building an ecosystem for publishing science and for funding science that can be broken down into 3 layers. So the first layer is a decentralized platform for interactive research objects. The core products here are the DeSci nodes, which I will show you in a minute, and the DeSci gateways. So gateways are basically going to be operated by institutions or by people, and they will literally be a window into the universe of research objects that are stored as DeSci nodes. And as a gateway operator, you will be able to basically curate the nodes that you want to show in your gateway. And by doing that, you basically create a local copy of that node on your server, and thereby you contribute and you become sort of like a steward, a custodian, a guarantor of a decentralized library of knowledge, right? So the gateway operators are running local copies of the content that they're interested in and that they want to sponsor. And gateway operators, they can also whitelist users and basically give them unlimited rights to store all different sorts of data on these DeSci nodes and to create as many nodes as they want, and so on and so forth. And as part of that basically bottom layer of what we're building, we're also building a Web3 native citation system that is based on unique identifiers, and that's called DeSci. And with that new citation system, we will finally have really unique permanent identifiers for everything that will not break and that can be used in a much more granular fashion as is currently possible, right? So with these digital identifiers, you can then literally cite a specific paragraph in a paper, or even a particular line of code, or a particular part of a data set, right? So it's extremely fine-grained, unbreakable, immutable. So that's the bottom layer, the entire infrastructure for these interactive research objects. Second layer is fair peer review. And here we're basically coming up with this concept of autonomous research communities, or ARCs. And I'll talk a little bit more about that on the next slide. And then finally, the third layer is efficient research funding, where our approach is that we want to create an ecosystem that is built around the concept of impact certificates, where impact certificates can be combined with existing financing mechanisms such as grants and prizes. And we think that this will ultimately enable funders to get a lot more impact for the money that they're spending on science. It will also enable a lot of new ways of actually experimenting with new financing models that will also give scientists new ways to actually get funding for the research that you want to carry out. And overall, I think there is a big chance that we will get a lot of positive feedback and adoption, not only from existing funding institutions, but also by completely new players who are going to come into the field and who will bring new money and new expertise into science funding. Okay, a couple of words about the autonomous research community. So the ARCs, they will ultimately be a open software kit that we will develop and make freely available. ARCs can be started and operated by any group of scientists, so it's really a grassroots movement, bottom-up approach. And each ARC will be a legally independent entity that is organized as an association under Swiss law. And we're planning to have an alpha test phase for the ARC toolkit next year. And the ARCs, so that toolkit will have various features. So first of all, it will have all the features that are necessary to do peer review for DeSci nodes. And the actual peer review process will be customizable. So each ARC can actually decide how exactly they want to do peer review. So who is going to be involved in what stages and what exactly they're going to review and how much they're going to weight these things and so on and so forth. It will also have an identity management and contribution tracking system, which is based on non-transferable tokens, so tokens that are actually person-specific. They will have a batch verification system, and they will have options for these ARCs to generate various revenue streams, primarily from digital assets. And they will also have options to track the performance of referees and to reward them accordingly. And that could be in the form of stipends or tokens or task-based rewards. And then the DeSci Foundation, which is our nonprofit, is going to play an important role in the governance of the system. So there's going to be a DeSci council where all the major stakeholders in science are going to be represented. So the scientists and the funding agencies and the gateway operators. And they will basically review these ARCs and decide which of them will get official approval by the DeSci Foundation. And those that do will get the right to participate in the digital economy, and they will have more options to generate revenue. And they may also get startup funds from the foundation to just get the entire thing up and running. So that's the idea of the ARCs. And couple of words about the badges. So we're really excited about this this idea of making basically the evaluation of research much more pluralistic than it currently is, right? So currently we have a system where the only stamp of approval that research typically gets is in which journal it actually ends up being published, right? And that is definitely a significant marker, but it's not very fine-grained because it basically convolutes a lot of different things. So primarily, of course, it's supposed to be a measure of impact, but we think that there is a bunch of other things that are important about research that we should explicitly acknowledge and verify. So the idea here is that we can operate with badges. Where each research object can over time accumulate numerous of these badges basically as quality markers, right? So there may be a badge that just says, okay, so this research object fulfills the basics. So the authors are identified, there's no conflicts of interest, licenses are available, it's checked for plagiarism and ethics, it has fair metadata. Then you may have badges that say, okay, so this one actually has open data, or this one has restrained data, but there is an access path available. And then you may have a badge that says, well, this actually is a research object that is reproducible, where the code and the data provided by the authors actually really reproduces the results that they're reporting. And you may have badges that actually qualify the type of contribution that a paper is making, right? So you may have a badge that says, this is a very sound, methodologically well carried out research, but it's not very novel. You may have a badge that says, this is highly speculative, not sure if this is actually going to replicate or not, but it's interesting and it's potentially path breaking. And you may have like these finer degrees that help us to just get a better grip of what characteristics a particular research contribution really has. Okay, all right, enough about the badges. So now I'm gonna try to switch over and show you guys our DeSci nodes demo. Let's see. All right. Okay, can you guys see the PDF node viewer with the menu on the right side? Yes? Okay, cool. Good. So basically, so DeSci nodes is literally just a web browser interface that anybody can use to create research objects and to read them and interact with them. So in general, it feels just like a regular PDF viewer that you would open in your browser. But then you notice a couple of things here that are different, right? So the first thing is that here on the upper right corner, you have this interaction field. When you click on it, you can actually see, well, there is a particular person that has actually signed in and that now also has the possibility to interact and to change the research object by going into editor mode, right? There may be a wallet of that person connected with that research node. And then if you click on this mysterious icon here, you get the entire menu of things that allow you to interact with that research object and to learn more about it, right? So the first thing you see is that there is this field of attributes. So these may be particular badges that have been granted by an ARC and that have been vouched for by referees that actually check these things. So here I'm showing you examples from an association that has it's the Association for Computing Machinery, or ACM, and they have badges for research artifacts. So here, the first one says artifacts available, verified. Okay, the second one says artifacts functional, verified. Third one says artifacts reusable, verified. And then there's two other badges that are not verified. One is results reproduced and results replicated. But these are things that, that may actually happen in the future, right? So that gives you an idea of like how badges could be used to give us a more fine-grained insight into how robust the reported research actually is and what type of characteristics it has. And then importantly, there is a field here for validation. So if you click on validation, it opens up a menu where you can basically stake a validation grant, and you can say for what, right? So in principle now, anybody with a Web3 wallet can come in and they can say, well, this is a research result where I want somebody to go in and to, for example, conduct the code audit, right? So you say code audit, and then you select an ARC that is supposed to do the code audit, and then you click next, and then you just put down some money, let's say to ETH or whatever, and then you mint a validation grant, and then it's up to the ARC to decide if they actually want to work on that. And similarly, you can do that to create incentives for researchers to actually carry out an independent replication study, or to do another round of independent code review, or to verify attributes of specific badges, right? So if you then scroll down, you see that for this particular research object, there were already several things validated. So there is a conference proceeding, and so there is an attribute verifier here who has actually vouched for these 3 badges here. And then you come to the part components. Okay, so the components of a research object are, first of all, the manuscript itself, and here you can actually browse through the annotation. So the DeSci nodes viewer and editor has the ability for anybody to start adding annotations directly into the PDF, and you can scroll through them. So for example, here you see this is an annotation. So somebody has put in a comment here and then some web links. And then you can also use LaTeX to add an annotation. So for example, you can add additional mathematical detail. And then probably most importantly, you also have basically reproducibility functions that we will enable at some point where you can literally, with one click of a button, reproduce the figure of a paper based on the code and the data that people have deposited and made part of the research object, right? So for example, if you click here on Generate Figure 2, you see now the code that is underlying Figure 2. And if you say reproducibility run, what this would do is it would trigger a compute over data that is basically being done decentrally. So it's not even running on your computer, it's decentrally run on the cloud. And the code is just being executed on the deposited data, and you see this is the result that you're getting. So that's our idea of how reproducibility should work, and that's how easy it should be. Yeah, so then you can have code in there, you can add presentations, you can have videos, supplementary information, and so on and so forth. And if you click on history here, you see who has interacted with that research object when, and so when certain things have been committed on chain. So there's, as I said, there is this immutable record, and you can actually scroll back in history and like look at the original versions and see who changed them and when. And then you have source information, so you will have metadata, you will have contributors, so authors, and you may also have organizations that have actually sponsored that research, right? So that's the main idea of the DeSci Nodes viewer and editor. And the DeSci Nodes, they're currently in alpha testing, which means that for a limited number of people, they can actually already play around with the prototype, and they can try to create their own research object and make it all work. And one of our team members is helping to write down bug reports, and we're fixing the bugs over the summer. So if any one of you actually wants to participate in this alpha testing, be welcome. So there is you can just shoot me a message or go on our Discord and sign up for it. And we would actually love to get more users, more actual scientists who were thinking about using something like that, and to give us feedback on how these things are actually working for them and if they like it or not. And then the idea is that we go into beta testing in September, so that will mean that the system will be openly available, but probably we're still going to run on testnet and not enable committing everything on chain yet. And then the final release is going to be where you will then also be able to truly commit things immutably on IPFS and on Ethereum, and yeah, where things can then literally be minted on an immutable blockchain. Okay, so I think that's it, what I wanted to talk about. Now let me just briefly go back to my slides and just show you the final slide. Here we go, sci-fi. All right, so join us, please do. We would love to have you guys on board. So this QR code here on the lower left corner will take you to our Discord channel. I've put down the web addresses here of the DeSci Foundation and DeSci Labs. You can find us on Twitter. You can shoot me an email. We'd love to have you guys involved. Thank you.